Hello everyone, this is Nilesh here once again. In the earlier classes, we discussed about the object-oriented programming in C#. We talked about the inheritance, polymorphism, abstract keyword, and so many small details. The last session was completely dedicated for C# interfaces. There, we discussed the classic interfaces as well as some advanced features like the default methods in C# 8.0. And now it's time to talk about the object class of .NET. Here we will also talk about some popular predefined interfaces like iClonable and IDisposable. Let us get started with the object class first. The object class is part of system namespace and it is ultimate base class of all .NET classes. Let it be the value types, let it be reference type, let it be predefined .NET classes, let it be user-defined .NET classes. This particular object class is kind of super cosmic class. It's kind of super base class for all the .NET classes. You can consider it as a root of .NET type hierarchy. And this particular class brings certain functionalities to the table. Let us talk about all these functionalities one by one. I will first begin with the functionality called a ToString. So this object class has built-in virtual method ToString, which returns the string representation of the object. But by default, it is only displaying the name of the class. What if I want to represent my object state into the stringized form? Yes, you can go ahead and you can override that method into the class. In fact, this is the most common practice we have. Earlier, we return display method. However, writing display method is not the common practice. The better idea is to override ToString method and the returned content can be displayed on console, or more popularly, these contents will be used for logging or showing into the debugger. Let us take a look at this practically. Let us go to the Visual Studio and create a new project for demonstrating these methods one by one. So I will first of all create a new project. Let's say this project is like console application and I name it as object and interfaces. I can click on next. Let me set this particular project as startup project and let me write a very simple class. Let's say class date. In this very simple date class, I can declare something day, month, year kind of variable. So I will have print. Of course, you can go ahead and write the different properties for the date class. Let me begin by writing the classic constructors, and I will also add the parameterize constructor. I can use the constructor chaining and let us set this to the default 1st January 2000. As I said, we can write the properties over here. Now, let me create the object of the date class. Date d1 is equal to new date. And let me write some date over here. In this particular case, if I try to print the d1 as a string, so I can call d1.toString. Note that though I'm not writing a toString method, by default, the toString method from the object class is inherited to this. And then I can run it. You can check the output. The default implementation of the object class toString method will only print the name of the class, nothing else. What if I want to display the state of the object? This is where I need to override this ToString method. And the easiest way of this implementation could be the string interpolation, where I can print, let's say, day dash month and this dot year. That's great. Let us take a look at now what will happen. Since ToString method is overridden due to runtime polymorphism, the method is called depending on a type of object. Here, the d1.toString will actually call the ToString implementation in the date class. Let me run this, and there you see the string representation of it. I hope that is interesting. Likewise, you can write the ToString for every next class that you will implement in your C# applications. Once you understood that, it's time to go ahead with the second method. The second method is GetType, and this GetType method is returning the type which represents the metadata about your .NET class or .NET type. Please note that this particular method is not a virtual method, so you cannot override that particular method. Let us go ahead and try to use that. So what I can do is d1.getType, and this getType will return me the type of date. Let me try to print this particular date type. So I'm mentioning d1's type is equal to date type. When I'm not giving anything over here and it is concatenated with a string, this will implicitly call ToString method of this particular type object. And you will see that by default, it will display the name of the class. So this particular type contains the full information about the metadata of the date class, because d1 is an object of date class. This particular metadata includes what kind of fields, constructors, methods, or properties present in that particular class. We will talk about this type class in detail when we will discuss about the reflection. So for time being, you've seen that the output of this was 15 January 2026, and you've seen output of this is nothing but the namespace name dot name of the class. Now that you have understood the two methods from the object class, it's time to go ahead, and there we will discuss about the next feature. This next feature is about the object equality. How do I check whether two objects are equal or not? And for that, I will create another date object, new date. Purposefully, I will provide the same date over here. And now I want to check whether this date 1 and date 2 are they equal or they are not equal. Please note that date over here is a class, it is a reference type. If you want to compare the equality of two objects, then I should be using the equals method. Currently, I had not written any equals method, but the object class have built-in equals. Let me check if I call that particular method, what exactly is outcome of it. So let's say that d1 equals d2, where I can say that d1 is same as d2. Otherwise, I want to put a message d1 is different than d2. That's it. Let me run and check this. Have you noted that d1 is different than d2? Now you might have question. In this particular case, I see exactly same content, but still it is saying that they are not same. What could be the reason? Please note equals method is not implemented by us. So it is calling the equals method of the base class, that is nothing but object class. And the default implementation of the object class will compare the references, will compare the addresses inside D1 and D2. It is not really comparing the actual object contents. Now, of course, D1 is a different object allocated at a different memory location, and D2 is another object allocated at another memory location. And that is the reason this equals is returning me false. But then you have question, what if I want to check the content of it? At that time, it is your responsibility to override the equals method. Note that the job of equals method should be comparing this object with the given other object. If both the objects are same, it should return true. Otherwise, it should return false. The very first, I will perform some safety checks. Number one, if other is equal to null, don't you think that you cannot compare this object with the null reference? And that is the reason I should be returning false over here. Then the second thing, it is common sense that one date has to be compared with another date only. If it is not comparing with the date, let's say a date you are trying to compare with some employee, does it ever make sense? Answer is no. And at that time, it should return false. So it is my responsibility to cross-check whether the given object is of the current class type or not. And that can be done by using is operator, or that can be done using as operator. How I can do that? Let me give a try. Let's say I'm calling it as a date is equal to other as date. You people well aware that if this particular other is not pointing to the date, by default, this will be null. And I can have a check. If that is equal to null, then I will return false. Now that I'm sure the current object this and the past object that both are of the date type, now comparison can be done. Now tell me when these two dates can be equal. But obviously when it's day, month and year, all three things are equal. And that can be done very quickly by writing this dot day is equal to that dot day, and this dot month equal to that dot month, and this dot year is equal to that dot year. That's it. Now I'm running the same thing once again, where I'm checking whether D1 and D2 are equal. Let me try to debug it. And while debugging, you will see that this equals will call my equals method, where other is not null. I have typecasted it to that object, and then you find that both of them have same day, same month and same year, and it will return true. The output is D1 is same as D2. Yes, this equals method is object class equal method. It is virtual in the base class, and that is the reason we can override it in the derived class. But if you go back to the object class, you will find that object class has got two static methods. Static method meaning by they are called directly on the class name. They are not called on the object. So I can make a call to the object dot equals, and where I'm comparing D1 is same as D2 or not. And again, inside this, I will have something similar check, where I'm printing D1 is same as D2 or D1 is different than D2. And you will still find that this is printing exactly same result. So what basically this particular equals method is all about? This equals method is static equals method of the object class. It returns true when object 1 and object 2 both are referring to the same object or both are null. So if two references pointing to the same object or both of them are pointing to null, then this equals will return true. Out of two references, if any one reference is null, then it will return false. In remaining all cases, which was our case, it will call the object1 dot equals object2. And then you realize that in my case, the d1 dot equals d2 is called internally. And of course, since d1, d2 both contents are same, it returned me true. So have you noticed that we have these equals as one of the virtual method, and we also have equals as a static method. Please note that there is one more method, and this one more method is nothing but called as a reference equals method. Now, what is a reference equal method? This reference equal method actually compare the addresses of two objects, and it will return true if they are pointing to the same memory locations. Now, in this particular example, you see that D1 is pointing to a separate memory location and D2 is pointing to a separate memory location. Though both have same content, they are not pointing to exactly same memory location. And that's why this reference equals returns false. If we can check over there, let's say instead of equals, I will use something called as a reference equals. And then I'm saying that D1 is same as D2. I'm talking about over here address comparison. And on the similar line, if it is different, it will talk about they are different on address comparison. Let me run this. And you see that at the address level, D1 and D2, they have different addresses. In case you have assigned something like this, date D2 is equal to D1. When I'm writing D2 is equal to D1, we are not creating a new object. The D2 reference is only pointing to the D1 object. And in that particular case, you can expect that D1 and D2 both to be absolutely same, even at the address level, because no new object is present over here. By the way, this particular behavior was exactly same when you are using a ready-made equal to operator. D1 equal to D2. This equal to operator for the reference types will by default compare the addresses. And you can check that this is also printing the same thing, that D1 and D2, they are different than each other. I repeat, this equal to operator for reference types will by default compare the memory addresses. For value type, yes, it can compare the content as well. Then what could be the difference between this equal to and reference equals? Let me tell you, C# has got a feature called as operator overloading. And if you want, going ahead, you can overload this particular operator so that it can check for the object state equality. However, reference equals will always keep checking only the addresses, nothing else. I hope you understood the equality check between the objects. Now that you have understood it, I want to talk about the next feature. So there is a method GetHashCode in the object class, and the hash code is nothing but one unique value representing the object state or object identity. Now, This is primarily useful when you want to store your object into a hash set or into the hash table. As we will learn about collections, we will discuss about this hash code concept in detail. This hash code method has got a very basic contract, very basic rule. If two objects are identical by equals method, then hash code must be same. However, if two objects are different in equals method, then their hash code can be same. Ideally, it should be different, but it can be same. So this particular hash code method will be really useful when you go for the collections like hash tables. If you are not implementing this method, then what will happen? By default, implementation of GetHashCode method in the object class returns you the hash code based on its memory location. If you want the hash code which is dependent on the state, then you should be overriding it. Let me have one quick and dummy implementation of this GetHashCode method. So I can override GetHashCode method. In this GetHashCode method, I want that the hash code should be dependent on day, month, and year, because these are the fields on which my equality is decided. So I can declare it as simple as, let's say, day plus month plus year. Will this be a valid function? Answer is yes, it will be valid function. However, in this particular function, there is a possibility that 1st February 2026 and 2nd January 2026 both will represent exactly same number. This is absolutely valid. If two objects are different, then they may have the same hash code, but it is recommended that you have the different values for the hash code as possible. So if you want, you can do certain changes into this. Maybe you want to multiply this with some number in general. You might want to multiply this with some number in general, and then you can have some year, and if you want to multiply it with again some number, it is absolutely fine. I'm trying that the different values or different state should return me the different hash code, which is strongly recommended. It will avoid something called as a collisions in the hash table. More about this we will discuss when we will talk about the collections in C#. Now you have understood the first few methods of the object class, and these methods discuss about ToString. We talked about GetType. We talk about the equals virtual method as well as equals and ReferenceEqual static methods. We discuss a little about the GetHashCode method. Now it's time to talk about the object cleanup. And this object cleanup or resource cleanup is done by the garbage collector. You recall that whenever any object is unreferenced, then garbage collector will automatically clean that object, will automatically reclaim memory of that. But what if my class is occupying some unmanaged resource like file, like database connection, like socket connection? Then that resource closing is not done by the garbage collector automatically. And this is where the programmer need to take care that if you are occupying any such unmanaged resource, any such platform level resource, then you should close that resource explicitly. And best place for that is to write the finalize method. So you find that this finalize method is a virtual method in the object class. and it is protected method in the object class. So what I can do is I can try to override this particular method in my class. If you want to override this particular method in your class, to write public or protected, override void finalize method. So I can try to write the finalize method like this. And if at all my class is occupying certain resources, then I will close the resource over here. Of course, in this particular date class, I do not have any such resource and I need not to write anything special over here. By the way, have you noted one thing? The method is protected in the base class. So if you want to override that method, the rule says that either you can have the same access specifier or you can widen that access specifier. So if the method is protected in the base class, then I can override it as protected method, or if I want, I can try to override it as a public method. However, though I can write the finalize method like this into other .NET languages, in C# we have one special syntax for writing the finalize method. And if you recall from our earlier classes, yes, we call it as the destructor. And typical way of writing a destructor is simply like this. This will internally override our finalize method. There is no direct provision of overriding finalize method in C#. Yes, other programming languages working on .NET, they might override it as a finalize method. In C#, we write it as a destructor directly. But do you also remember that this particular method is, or destructor, is to be called by the garbage collector. But the garbage collector of .NET is non-deterministic. Means it cannot be guaranteed that it will be called for sure. And this is where a standard comes into picture. We discussed that the interfaces are used to design standards. And there is one standard given to deterministically clean up the resources. And that standard is called as disposable or IDisposable. If you want to clean up your class resources, then you should write your class inherited from IDisposable, and then you have to override a method called as a dispose method. Now, instead of writing the resource closing work into this, you can write that code into the dispose method. For time being, since my date class doesn't occupy any unmanaged resource, there is nothing much I can do either in destructor or dispose method. This particular code I have written only for sake of demonstration, but I will just write one console.write line, which is indicating that date.finalize is called, and another console.write line where I will show that date.dispose is called. Let me give a try on this. What if I want to create another object and check whether that object is getting destroyed or not? That can be done by creating another object. Let's say d1 is equal to new date. And while creating the date object, I can pass again some value, let's say 1st January 2026. Later on, when I make this d1 is equal to null, means that my object is unreferenced, I can try to cross check whether my destructor is called or not. Before that, let me just print the d1 ToString, and you see the output. Though my object is unreferenced, you've seen that the destructor is not called, because I told you that garbage collector of .NET is non-deterministic. It will come into picture only when there is need to reclaim the memory. Right now, we are not occupying too many objects, and that is the reason it is not necessary that garbage collector should come and immediately reclaim the memory. Anyway, so this is where you see that the destructor is not getting invoked. So what is more reliable way of cleaning up the resource? I would suggest that you call the dispose method manually. And when you call the dispose method manually, then it is guaranteed that the dispose will be executed for sure. But then people might ask the question, what if I forget to call the dispose method? Well, there are chances that you might forget calling the dispose method, and in that particular case, your resource might get leakaged. To handle this, people have some different suggestion. People suggest that do not create the object like this, where you might forget calling the dispose method later. Instead, .NET has provided one keyword called as the using. And inside using block, you can create a new object where you can pass, let's say 2 February 2026. In this particular case, you can try to access this D2 ToString or any other use of that particular object you want to do. You can do it. And later on, please note that though I'm not calling dispose method, running this program, the dispose is automatically called. The speciality of the using block is moment this using block is completed, it will internally call the dispose method of that particular class. Common sense is that using can only be used with any class object which is inherited from IDisposable interface. If your class is not inherited from IDisposable interface, there is no point in using this particular using block here. You will find the actual use of this using block when we discuss about the file IO and database connectivity and so many things, where closing the resources is really important. Now that you understood about the object cleanup, it is time to go ahead and talk about the next functionality in the object class. Now this next functionality about the object class talks about the copying the objects, and you will find that the object class has got a method called as a member-wise clone. This protected member-wise clone method will create a copy of the current object. It will create the copy of this object, and this copy will be created as a field by field copy, or you can call it as a shallow copy. Please make a note, this particular method is not a virtual method, meaning by being a programmer, you can only call this method, but you cannot override this particular method. So let us take an example how we can do that. So let me go ahead, and in this particular class, I will write one method called as ShallowCopy, which is returning date. I name it as ShallowCopy, or you may write only the name, let's say copy. Now inside this, I want to create a copy of this object. How you can create the copy of this object? You can probably do it manually, where you can create a temporary copy, and in the temporary copy, you can assign day, month, year, and then you can return this. But this is too much, especially when your object is big enough. Do we have any shortcut for this? Yes, this is exactly field by field copy is done by object class member-wise clone. So instead of doing all this jugglery, I can simply make a call to this dot member-wise clone. And this dot member-wise clone will internally create a temporary object and will initialize each field as a copy of this object. Please note that return type of member-wise clone is object type. So you need to downcast it to your date type. That's it. Nothing else you need to do over here. That's wonderful. Let us give a try on this. Let me write another main, and into that main we will create one more object. Let's say date d1 is equal to new date, and I will pass 1st January 2026. I can print display data d1 is equal to d1, and now I want to create d2 as a copy of d1. Yes, that can be done straight away by saying d1 dot copy. Good. Let me quickly first print it and show you the output. And you will find that d1 and d2 both will have exactly same content, that is 1st January 2026. But are both of them pointing to the same memory location? We can have a quick check by using equal to operator or reference equals, and it will reveal that these two objects have different memory location. So d1 is same as d2. Otherwise, I want to print a message cw d1 is different than d2. In this particular case, d1 and d2, they will have different memory location, and that's why you see the result d1 is different than d2. I hope you understood this. The member-wise clone is only creating a copy of it. Let me take it another example. Suppose that I want to write one more class called as a employee class, and this employee class, consider that I have only two data members. Maybe one data member I have is ID and I have salary. What I can do? I can write a ShallowCopy method inside display employee class. Just now we already see that each and every class is directly or indirectly inherited from employee class. This employee class is by default inherited from the object class. And that is the reason inside ShallowCopy we have only written base dot member-wise clone. Here the base is representing the object class, and then it will create a member-wise clone. It will create a ShallowCopy of the current object, which is nothing but this object, and this E will be that copy. We can try to call it from the main. Here I have E1 is equal to new employee, and then I'm trying to create a copy E2 is equal to E1 dot ShallowCopy. Putting it diagrammatically, you will see that E1 is, let's say, at the location 100, which is storing the employee ID 1, and let's say salary is equal to 1000. But when I say ShallowCopy, it will internally make a call to the base dot member-wise clone, which will create a new object at a new memory location, let's say 200, but it will contain exactly same data. So ID is equal to 1, salary is equal to 1000, and it will return it back to the E2. So this is how internally the member-wise clone or ShallowCopy can be created. But there is one more interface in the .NET, and that interface is iClonable. iClonable interface is defined as a standard to create the copy of the current object. Yes, we can always write a method by the name copy or ShallowCopy as of your choice, but iClonable interface gives you guarantee that your class has got some copy feature. Let us try to write it quickly in the date class first. So where I will write my date class inherited from iClonable. In this particular case, I have to write the method public object clone. This public object clone is implementation of iClonable, and you can directly make a call to this dot member-wise clone, or you may write this particular same logic over here, and that should work well. Or for that sake, you can even call already written the copy method over here. It is your choice how exactly you want to implement. But writing the class inherited from iClonable gives guarantee to all other developer, all your teammates, that in your class you have taken care of creating a copy. By the way, what kind of copy is this? Is it a shallow copy or is it something called a deep copy? Answer is iClonable only talks about the copy to be created. It is developer decision what kind of copy he or she want to create. So instead of using the copy method, I might go for calling the clone method over here. So d.clone. But have you noted that the clone return type we have written as the object? So if you are using it into the main, I need to typecast it back to the date, and then this will produce me exactly same results. But in employee, I want to explain you a bit advanced concept. And for that purpose, let me first explain you another OOP feature. And that OOP feature talks about has a relationship. In object-oriented language, is a relationship is represented as inheritance, and has a relationship is represented with association, aggregation, or composition. So let us first understand what exactly the association is. Association is talking about general has a relationship or uses relationship. In a diagram, it is displayed as a single line. There is no ownership of one object with another, or there is no life cycle tie-up. A simple example is the car has a driver. Now you know that the car may have multiple drivers over the time, or a driver may change his car. They are not directly tied up with each other, but for time being, yes, car has a driver. The similar example over here is classroom has a teacher. So after the period is over, the teacher may go to the another classroom, and this classroom might have another teacher. So this kind of example is association. Here we do not talk about any one object is owning another object. They are independent, but they are getting used together for time being. Then we have the second example, let's say aggregation. The aggregation example is talking about the whole part relationship or kind of part of relationship. But in this particular case, we have weak ownership, means the outer object is owning the inner object. The ownership is not very strong. A simple example, the classroom has chairs. Let's say one particular classroom is having the 20 chairs. But don't you think that you can easily remove the chairs from the classroom? If you want, you can add new chairs in the classroom. So though we have the classroom has chairs, the chair itself can exist without classroom. And that is the reason this ownership is not a strong ownership. Such kind of example is referred as a aggregation. Then there comes the next example, something called as a composition. The classroom has wall. Now classroom is made up of 4 walls, and that is a structural part of the classroom. Without wall, you cannot have classroom, and without classroom, there is no significance to that wall. This whole part relationship is a strong ownership. When your classroom is destroyed, eventually the walls are also destroyed. This kind of example is referred as a composition. Another classic example for the composition could be, let's say, car has engine. Now, what about one example that I'm talking over here, like employee has a joining date. Don't you think that this joining date is very much related and relevant to the employee? If there is no employee, there is no point in talking about his joining date as well. So this talks about the strong ownership. The employee owns the joining date. This is where it is composition example. Now, if I want to write an employee class which is having maybe ID, let's say salary, and then the joining date, and then we can create the object of it. If we create the object of employee with the joining date, it should look something like this. Let me try to put it in a code and then explain you further. Let me go ahead and talk about the class employee. Over here, as we planned, I will have one ID. Maybe I'm putting a salary, and then I want to use something called as a joining date. So date, and I'm calling it a joining. That's it. Now you can write the constructor. So in a constructor, for time being, I can keep it empty, but I want to also write a parameterized constructor. In the parameterized constructor, I want to pass ID, I want to pass salary, I want to pass joining date as well. Now let me complete my parameterless constructor, where I will use constructor chaining, and the default ID is, let's say, 1, default salary is, let's say, 0.0, and default date of joining is, let's say, 1st January 2000. You can give any other joining date. It is your choice. Or if you want, for time being, you can also keep it null. Now you can continue further and you can implement the properties for the employee. So let me quickly create the properties. Let me also write the salary property. That's good. And then we can also write the joining date property. That's wonderful. You may also write ToString method for practice. Let's say over here, I want to display information about employee, where ID is equal to this dot ID. Let's say salary is equal to this dot salary. And finally, the joining date is equal to this dot joining. By default, it will call ToString method. If you just want to make it more readable, you can call ToString method explicitly. You can test this employee class over here. Let me write one more main for that. And inside this, I will create employee object. Let me pass ID is equal to 1, salary is equal to 1000, and let's say date of joining is 1st January 2025. If I try to create object like this, it will diagrammatically show exactly like this, where the employee is, let's say, created at the location 100. It is storing the ID is equal to 1, salary 1000, and joining date, it is a reference type. So it will not be stored inside employee. Rather, it will be only having a reference which will point to the actual date object, maybe at the location 200, and it will store 1st January 2025. I hope you understood how composition is working over here. Let me quickly print this employee object. And you can cross check. Is it printing the data as per the given values? Yes, that is wonderful. Now it's time that I want to create the copy of the employee. And now it will give you more clarity about creating a shallow copy or a deep copy. Let me first again go with the earlier shallow copy example. What I'll do is that I will write one method inside my employee class, which will return me the shallow copy. Let's say employee, and then I will have shallow copy method. As you are aware, the shallow copy method should be created very easily just by calling this dot memberwise clone. In fact, your employee class itself is inherited by default from the object class. So if you want, you may use base.memberwise clone. Both will be same. And that will return me the temporary object. The return type of memberwise clone is the object type. So I will downcast it to the employee and then I will return temp from here. What will happen if I call this shallow copy method? So let me write employee e2 is equal to e1 dot shallow copy. And we can try to print this e2 over here. Let me run this. And you see that e2 is having exactly same content as of this. But e1 and e2 both are pointing to the same memory location. Answer is no. It is creating a copy of it. Now, what exactly happened behind the scene? If you want to check that, let me show you this diagram. In this particular case, E1's copy is created into E2 and our ID is copied. Then the salary is copied, but the join itself is a reference. It is just a pointer. It is not the whole object over there. And that is the reason it has even created the copy of the join reference. Only the address 200 is copied as it is over here. And that is the reason both of them, they are pointing to the same date object. Have you noted that? Now, in this particular case, you will find that if I do any changes into the events joining date, by default, it will reflect into the E2 joining date. Or if I try to do the changes in E2 joining date, it will reflect in the event joining date. You can see that quickly. Let me just try this. Let me try to modify E1 dot joining. Let's say I'm changing the year from 2025 to, let's say, 2026. And then let me print this E1 over here. Let me also try to print E2 over here. And you will see that these changes are applied to both E1 as well as E2. Why so? Because both of them referring to the same object. So whenever I'm modifying E1.joining.year, so that modification is applicable to this date object. And this date object is shared between E1 as well as E2. This is something I call it as a shallow copy. Then the question is, what exactly deep copy is all about? The deep copy talks about creating the separate copy of the object. And if the object has got references to some external object, then we also want to have the separate copy for those external objects as well. We want these objects should look exactly independent of each other. There should not be any common or any shared component between them. That particular stuff, you can consider it as deep copy. So how you can implement it? I guess that should be very easy. What we can do is we can first simply create the shallow copy, because the member-wise clone method by default gives me shallow copy. If I create a shallow copy, automatically I'm getting a copy for ID, salary, but only problem is the content object is getting shared. The new reference is pointing to the existing object only. So the next thing that I can do is I can create a separate copy of this content object. I will have the separate copy of the date object. Now, let us take a look at if I create a dip copy, then how exactly it will look, where employee E3 will be pointing to the employee object, and then that employee object joining date will be pointing to a separate date object, so that our E1 object and E3 object, they will be completely independent of each other. Any change in E1 or its content object will not be reflected into E3 object and vice versa. How you will implement this? As I said that we will still make a call to the member-wise clone, but after calling the member-wise clone, we will explicitly create the copy of the content object. Let me go to the employee class once again, and let me write employee deep copy. The first step will be still same, no change. Now, I just want to create the separate copy of the joining date, and that can be done by saying temp dot joining is equal to this dot joining, and you recall we already had written some copy or clone method inside the date class. Let us use that to create the separate copy for the joining date. This will take care of creating a separate copy of the joining date, maybe at the address 500. And now whatever is this new temporary copy is created at the location 400, that we can return from here. In this particular example, employee was having only one reference which was pointing to the external object. If you have multiple references, it is your responsibility to create the separate deep copy for each of these references over here. This is example of shallow copy and deep copy. Now we can create this deep copy employee E3 is equal to E1 dot deep copy. And now we will try to print E1 and E3 once again. Let me first print E1 and then let me print E3. You see that E1 and E3 both are same. Now what will happen if I try to modify this particular E1 once again? If I modified E1's joining year, will it be reflected into E3? Answer is no, because in this particular case, E1's joining is pointing to a separate date object and E3 joining is pointing to a separate date object. So when I run this, you see that E1's date is modified to 2026, but E3's date is still pointing to 2025, which you can see over here. The changes are done in this E1, but the changes are not done in this particular E3's joining date. I hope this gives you clarity. Before I wind up this shallow copy and deep copy topic, I want to give you a real life example. You might have heard of shallow fry and deep fry. So when we do shallow fry, what exactly happened? In that particular case, the fry is done only on the upper layer of the substance. So oil is only spread on the upper layer and the inner layers remains untouched. But when we go for deep fry, the oil penetrates through all the layers to the core, and the complete substance in and out get fried. This is exactly similar happening in this particular case. When we go for shallow copy, you see that E1 and E2, only the first layer is copied, but the inner layer, that is inner object, is not copied separately. That is example of shallow copy. But when we went for deep copy, in deep copy, the outer layer, that is employee, is copied, no doubt, but along with that, the inner object, that date object, is also copied explicitly. In this particular session, we talked about the important methods about the object class, and we talked about two important predefined interfaces. First was IDisposable and second was iClonable. I hope you found this session very useful. Thank you very much. See you in the next session.